In this tutorial, we will show how to build an autoregressive time series model. An autoregressive model is when a value from a time series is digressed on previous values from the same time series. So for a AR1 model, the current value will be just depend on the previous value. We will use the stats model Arima package to illustrate the AR model. First, we will need to do an autocorrelation analysis. The autocorrelation analysis helps in detecting hidden patterns and seasonality in the time series. So it is especially important when you intend to use the Arima model for forecasting, because the autocorrelation analysis will help to identify the AR and the MA parameters for the Arima model. So we will define a function to plot the autocorrelation ACF and the partial autocorrelation PACF plots using the stats model package. Next, we will try out the AR modeling on some simulated data. First, we simulate an AR1 time series with the AR parameter of minus 0.5. So this is the time series that is generated, and this is the autocorrelation plot and the partial autocorrelation plots. We can see from the partial autocorrelation plot there is one lag that is significant, but the autocorrelation plot show that it is dependent on a few laps. Next, we will fit the AR model to the simulated data using the stats model Arima package. In order to model the AR1 model, we choose the order to be 1, 0, 0, and the result of the fitting is shown below. We can see that the result agrees well with our simulated data. Next, we will simulate on the AR2 time series with two AR parameters, minus 0.5 and 0.3. This is the time series that is generated, and this is the autocorrelation and the partial autocorrelation plots. We can see there are two lags in the partial autocorrelation plots that are significant. Next, we will try to fit the simulated data to the AR2 model by choosing the order to be 2, 0, 0. Again, the fitting result is consistent with the simulated data. Similarly, we tried out on the AR3 models, and we can see that the simulated data agree well with the fitting result. Now, let's look at how to apply AR modeling on stock market data. We will use the Yahoo Finance API to download the Microsoft data, and we take a look at the data. We can see that the stock price data have increased steadily over the years, and from the autocorrelation plot we can see that there's a lot of dependency over all the previous labs, but the partial autocorrelation plot show that there's only one lab that is significant. So this suggests us to use an AR model of order 1. So we apply the AR model with 100 order and we do the fit, and this is our AR modeling. This concludes the video on AR modeling. The code is can be downloaded below. Feel free to give your comments. Thank you very much.